Assalamualaikum warahmatullahi wabarakatuh. So now we'll continue on the solar radiation topic for heating and cooling load subject. So previously we have calculated until the sol here, and now we will extend our study to determine H, B, phi, and theta here. So the table that we are using to use is same table, which is the solar data for 21st day of each month. And then we are going to extend our study to use the declination degree ET, A, B, C for the rest of the question. So in your formula and appendix table, please refer to the table of solar data for 21st day of each month and the outdoor design condition table. So basically the question will be referred to the state that we have the data of outdoor design condition here. Alright, so now the solar radiation usually will be referred to the sun, which is referred to our building here. So in this study, for example, the location of the building on the north area is here. So but somehow the building location and building rotation orientation will be referred to the question. So usually for the sunrise, usually the sun will rise from the east to the west. So usually before noon, the sun will be located either here or here. And then the evening after noon, after 12 noon, the location of the sun usually will be referred here or here. So we'll see more in the next example. So some of the question that we are going to calculate here is which is the sin beta, cos phi, and then cos theta here. And then the one that I'm using to use is declination, differentials, longitude, and then the latitude here. Alright, so the phi is referred to the solar azimuth here, and then the lambda is zenith angle, and then the beta is solar altitude. So if this is the example, if the sun is here, so the lambda will be located, this is the direct radiation of the sun here, but somehow from the sun to the ground here is what we call the beta here, and then the lambda will be here, and then the phi will be calculated and measured from the south to the beta line here. So this is the one that you are going to focus on, and then you have, for example, lambda plus beta is equal 90 degree, and the gamma here equal to phi plus or minus the lambda. We'll see how we want to determine either it is plus or minus here. So in the example that I will give to you will be clearly state how we are going to plus or minus the formula. Alright, so this is the formula that we are using to use until the angle of incidence. So the formula of solar time is same like previous one, which is the T sol is equal to time standard, L standard minus L location times 4 plus ET, equation of time. So the time standard, either we want to find T sol or T standard, and then the L standard will be constant, right? And then the hour of angle that we are going to calculate here is H equal to 12 minus T sol. Or if the time is more than 12, so it is automatically the T sol will be minus to 12 here. And then we are going to extend our study, our calculation. Now we are going to solar altitude angle, which is the beta. So sin beta equal to cos L cos H cos alpha plus sin L sin alpha. So how we want to find the L, H, alpha basically is from the table. So cos H is from here. Alpha is from the table, L is also from the table. So after we find the sine beta data, we are going to put in the solar azimuth angle of phi. Cos phi is equal to sine beta. Beta will be put here. Sine L from table also, sine alpha also the same table from the question. To put the sine alpha, cos beta is here also, sine cos beta, cos L. So from the cos phi, we are going to cos theta or angle of incident. So the cos beta is from here, cos beta, then cos gamma. We are going to calculate. And then how to find the gamma is either phi plus or minus with lambda. So let's go to the first example. We have to determine the solar altitude and solar azimuth. Solar altitude and solar azimuth at 11:30 AM of 21st September in Bandar Baru Bangi. So now we are going to determine the solar altitude and solar azimuth at 11:30 AM on 21st September in Bandar Baru Bangi. So the first one we have to we have to find the solar time, T sol. So T sol here is equal to time standard minus L standard minus L location times 4 plus ET. So please refer to the month, which is the September, and the location is in Bandar Baru Bangi. So the time standard that are given is 11:30, and then 120 is constant, right? Then minus 101 degree 48 minute times 4 plus 7.5. So how to find allocation here? Refer to the table of solar outdoor design condition of Bandar Baru Bangi. Allocation is for Bandar Baru Bangi is 101.48 degree minutes, and then the ET, please look into the solar data for 21st day of each month, which is on the September. The ET equation of time. This is the equation of time. Refer to the month of September. So you get the 7.5 here. So 11:30 minus 65.3 is the calculation from here to here, and then minus 11:30 minus 1 hour and 5 minutes. So you just divide 65.3 to 60, then you get 1 hour and 05 minutes. Or the time is 10:25 AM. So we have to next find the hour of angle here, H. H is equal to 12 or 12 minus the sol here. So H will be 12 minus T sol. So like previous one I say, if the T sol is less than 12, so it is 12 minus with T sol here. So 12 minus 10:25. 10:25 is put here. Then you get 1 hour and 35 minutes. So 1 hour and 35 minutes you have, or 1.58 hour, 1 hour and 35 minutes, 0.35 you divide by 60, and then you get the 1.58 hour times 15. So how to find the 0.5 0.58 here? So 35 minutes here, 35 you just divide by 60, because 1 hour is 60 minutes. Here 35 you will get the answer 0.5833. So just round it up, is 1.58 hour times the 15 degree. So 15 degree is equal to 1 hour time. So you get the answer is 23.7 degree. So 15 degree is quite constant. Alright. Now, next one, we have to find the solar altitude angle or beta. So the formula of is sine beta, cos L, cos H, cos alpha, sine L, sine alpha. How to find the cos L is from the table of the table of Bandar Baru Bangi. So the L is I'm sorry. Two degree and 56 minutes refer to the table Bandar Baru Bangi of latitude. And then the cos H is refer to the previous that we are calculate before this cos H. And then the alpha is cos alpha. How to find alpha? Refer to Bandar Baru Bangi on the month of September. It is declination degree. Here, oh sorry, declination degree here for the alpha. And then the sine L is same here, 2 degree and 56 minutes. Sine alpha is refer to the table of declination degree. So you get the answer of 0.9145 here. So you get the beta. You have to shift sine the beta to get the 66.13 degree. Alright. Next one, after we calculate the solar altitude angle, we have to find the solar azimuth angle of phi. Cos phi is sine beta that you have calculated here. You just put here beta. L is same here, 2 degree and 56 minutes. Cos alpha is that same here. You have find 23. Refer to the month of September is 0, and then cos beta is that you have calculated here, and then the cos L is refer to the table, which is the 2 degree 56 minutes. 2 degree and 66 minutes is refer to the latitudes here. So cos phi is equal to 0.115. So shift sign, and then you get the answer of 83.21. So please remember that solar azimuth angle is always measured from south. So where is 83.21 degree here? So you have to remember this is the location of north, and then the time is 11:30 a.m. right? So it is either here or here. If evening, it is here, but it is in the morning, either here or here. So from the south, solar azimuth 83.21, it is measured from here to here. 83.21 here, because from here south to east it is 90 degree. So until here is 83.21. The beta is from the line of here to here, and then this is the line of sun here. Alright. See you in the next video for the next example. Thank you.